All right, guys, we're going to take a look at kind of a older concept that we've been practicing all year, but we're going to add a bit of a new wrinkle to it. The Pythagorean Theorem is by no means a new idea for us. In case you forgot, Pythagorean Theorem is represented by this equation here. A squared plus B squared equals C squared. All right. C is really, in my opinion, the most important piece. This must be the longest side of the triangle, called the hypotenuse. As long as you get that one put in the right place, A and B really don't matter. In case you ever have a little bit of confusion, I don't know, is this the longest? Is this the longest? The right angle is always pointing at the longest side. So if we're going to try and apply the Pythagorean theorem here, this would be at A and B. It doesn't matter which one goes where. All right, 4 squared plus 8 squared equals, and you can leave that as C squared, or you can put a variable in there. Doesn't really matter. Okay, in order to handle this, all right, the order of operations says we got to handle the exponents first. 4 squared is 16. 8 squared is 64. If we put those together, we got 80 equals C squared. Obviously, this does not measure 80. That's what this side squared is. So if I want to find out what C is, I would square root both sides. All right. Now, the new little wrinkle is, well, do you and I know what the square root of 80 is? I know that 9 squared is 81, so this is pretty close to 9. I can plug it into a calculator and round, but we want to work on a bit of a new skill. All right, that new skill is called simplifying radicals. Now, a radical is not a crazy person. All right, a radical is simply this symbol here. This is a radical. All right, sometimes we call it a root. So when there's just the symbol, that's a square root. You can actually do a third root, fourth root, but that's not necessarily our focus today. All right. The main idea is you and I don't really know what the square root of 80, but we're going to look inside there and see if we can find something that we can square root. All right. So I've got a bit of a procedure on how to do this, and some of it's a little childish, but I think it does help in the long run. All right. I like to call this this process, I kind of call it the house breakdown. That's what I kind of call it, because my step one is I draw a house. Yes, this sounds very childish, but after doing this for 20 years, I have a method to my madness. So if you see what I drew here, kind of looks like a house. The 80 is inside the house. All right. Now what we want to do is we want to start breaking down 80 into the numbers that multiply to get 80. All right, because 80 is not prime. There's numbers that divide evenly into 80. All right, so we want to find what's called the prime factorization. Now, there are tricks to this, but we're going to go slow at the beginning. So I want to break 80 into two numbers that multiply to get 80. You got a bunch of options. All right, I happen to know that 80 is 8 times 10. You can do 2 times 40. All right, as long as you have correct numbers, we're going to end up in the same place. Neither one of these are prime, so I got to keep going. 8 is 2 times 4. All right. Now, one of my procedures here is I want you to, anytime you come across a prime number, I want you to circle the primes, because one of the common mistakes is we forget, or we misplace, or we lose one of the prime numbers. So 2 is prime. There's nothing, 2 can't break down into anything besides 1 and 2. 4 can break down into 2 and 2. Both are prime. I don't want to lose any of these prime numbers. 10 breaks down to 2, which is prime, and 5. 5 happens to be prime also. Okay, so what we're looking at, you wouldn't have to do this, but I want you to understand that the square root of 80 is the same thing as the square root of 4 2's multiplied by each other and a 5. All right, so if you want to find something you can square root, you want to find pairs. If you find a pair of numbers, see, we have 2 2's. We have a pair of 2's. Well, 2 times 2 is 4, and if you knew the square root of 4 is 2. So if you find a pair, we can cross off 2 of them, and we can take one of those numbers outside. That's exactly what you're doing when you try and square root of something. The square root of 25 is 5 because 25 is 5 times 5. We needed a pair of 5's. All right. If there are any more pairs, there's another pair of 2's. Again, I cross off 2 and I take 1 out. Well, that's not 22. It's 2 times 2 on the outside. This is all linked through multiplication. Try and remember the word factor means to multiply. We're trying to find the prime numbers that multiply to get our original number. Okay. So we found pairs. All right. We crossed off 2. We took 1 out of the house. All we need to do on step 6 is decide what made it outside the house and what still is in the radical or in the house. So over here, my final answer, again, is going to be something outside the house and something still in the house. The items that made it outside the house, 2 times 2, which is 4. Stuff that's still in the house. We are not looking at the things that broke down. We're not looking at any of those numbers, only the circled items. The only thing left inside that house is the number 5. And I can even check my work. So if I do the square root of 80, again, this is some decimal that I knew was close to 9, but I'm not going to be able to come up with that number. But if I put in my answer, 4 square root of 5, and I hit enter, I better get the exact same decimal, otherwise I've made a mistake. So it's a quick way that you can check your work. All right, those two things are the same. I haven't made any mistakes. All right, so just to show you a slightly quicker version of this, all right, let's try it again with the square root of 48. So if we remember the procedure, I like to draw a house. All right, 48 happens to be, let's say we knew that that was 4 times 12. Well, the faster thing to do is if you ever run into a number that you know the square root of, you can just square root that number. The square root of 4 is 2. I don't know the square root of 12, so let's break it down. Again, if you missed that, you'd end up with 2 2's, and you'd still be back at my main process. Ooh, there's another 4. The square root of 4 is 2. So I broke down 48, I broke down 12, and I still have 1 prime left. That means my answer, I have 2 times 2 on the outside, 4, and I still have a 3 on the inside. Again, I can check my work by putting the square root of 48 and 4 square root of 3 in the calculator. If I got the same thing, I'm doing pretty good. So you're going to have to use the Pythagorean Theorem on this homework, and at the same time, we want to work on this practice of simplifying radicals. This is an equivalent value. If I try and put in the decimal 6.9, these are close, but this is an approximate value. Anytime we can be equivalent, this is going to be the better and more accurate answer. Rounding just gets us a little further off. So hopefully that makes sense. We'll practice when we get to class.